Hello students, this is Monica Bansal from Bullseye. I have been teaching quantitative aptitude and reasoning for last 10 years. As all of you know, that number system is an important topic in every competitive exam. So today we are here to discuss an integral part of number system, that is divisibility. Before starting this session, let's have an overview. First of all, we will discuss the concept of successive division. Then we will do application of divisibility rules. Then there will be some question based on divisibility. Then you will have some practice questions and the answer key. First of all, let us know the meaning of successive division. Let us take a random number. Let it be 55 and divide 55 by 9 and 7 respectively. So if we divide 55 by 9, the quotient will be 6 and remainder will be 1. Now what do you mean by successive division? It means at the second step, the old quotient will become the new dividend. If we divide it by 7, quotient will be 0 and the remainder will be 6. So we can say 55 when divided by 9 and 7 respectively, remainders are 1 and 6 respectively. Now we took 55 and we got remainders. But what if the process is reversed? The reverse question is asked. We'll apply the same criteria. Our question says, find a number which when divided by 9 and 7 gives remainder 1 and 6 respectively. So let us take the quotient to be k. As we know that dividend is equal to divisor into quotient plus remainder. That's why this number can be written as 7k plus 6. Now this was the old quotient. So this number will become 9 into 7k plus 6 plus 1. Again applying the same thing, that dividend is equal to divisor into quotient plus remainder, which comes out to be 63k plus 55. For k is equal to 0, it will give you the least such number, which is 55 as we have discussed. And if you put k as 1, it will give you second such least number. And if you put 2, it will give you third least number, and so on. Now let us see the shortcut. So our question was a number when successively divided by 9 and 7 gives remainders 1 and 6 respectively. We'll do it directly. For the least such number, the quotient we took was 0. So let us take the quotient to be 0. And we know that we always multiply quotient and divisor. We add up the remainder. So 7 into 0 will give you 0. Add up these two things, the result and 6, which will give you 6. Now time to move to previous division. We'll multiply the result by the divisor, which will give you 54 sorry. Then you will add up the remainder once again, which will give you 55, and that is the final answer. That is the least such number which is satisfying these two conditions. And what about the next least number? Simply add up multiplication of these two, 9 and 7. That will be the second least number. If you add 63 two times, it will give you third least number, and so on. That is the meaning of successive division. Now let us move to questions. It says a number when successively divided by 5 and 9 gives remainders 2 and 4 respectively. Again we want to find least such number. We'll apply the shortcut only. For least number, we'll take quotient as 0, which will give you 0. Add up the remainder, which will give you 4. Now multiply the result with the previous divisor, which will give you 20. Then add the remainder to this result. which will give you 22, and 22 will be the final answer for this question. Now let us move a level higher. In the next question, we will have three divisors. Question says, a number when successively divided by 3, 5 and 7 gives remainders 2, 4 and 3 respectively. What is the remainder when such second least number, these are the keywords here, second least number is divided by 35. So to solve this question, first of all, we will find such second least number. For the least number, we take quotient to be 0. But for second least number, we'll take quotient to be 1. It will give you 7. Then add up the remainder 3. So you are getting 10 as the result. Then multiply 10 by 5. Every time you are multiplying divisors and you are adding remainders. It will give you 50. Then add up the remainder, which will give you 54. Then multiply this 54 by 3. You are getting 162. Then add 2 to this, which will give you 164. So 164 is such second least number. So if we divide 164 by 35, we will get 24 as the remainder. And this is the answer. Now let us take one more good question on divisibility. It says, a number when divided by 221 gives remainder 101. What will be the remainder when the same number is divided by 13? First of all, let us discuss the meaning of this question. It says a number n, let us assume the number to be n. When divided by 221, we are getting a remainder of 101. So as we know that dividend is equal to divisor into quotient plus remainder. So let the quotient be k. So we can safely assume this n to be 221 k plus 101. Now the same number is divided by 13. But we don't know the value of k. Is it required? No, this is not required here. Why so? Let us see. Our number is 221k plus 101 and we want to divide it by 13. As we know that this 221 that can be written as 13 into 17. So this complete expression will be divisible by 13. So it will give a remainder of 0. That's why we will take this 101 and will divide it by 13. So what will be the remainder? It will be 10 because 13 sevens are 91. 101 when divided by 13 will give you remainder 10. No need to find k here. That's why our final answer will be 10. What if the divisor is changed? Let us take the divisor as say 15. In this case, we cannot neglect the first term here because for k's various values, answer will be changed. In the previous case, 221 itself was a multiple of the divisor, but in this case, this is not so. That's why answer in this case will be cannot be determined. We cannot simply say that 101 when divided by 15, remainder is 11. No, this is not so. Because here the first term, which is a multiple of 221, is not a multiple of 15, which was the divisor. That's why we can answer these type of question if particularly this term is multiple of the divisors. So answer was 10 for the previous question. This is a question based on divisibility rule of 11, which you must be aware of. It says if $and hash can take any value from 0 to 9 individually, it means they are digits, then how many different numbers of the form 2, 3, 4, 5 hash $, which is a 6-digit number, exist which are divisible by 11. So the given number is, let us apply the divisibility rule of 11. We'll take the sum of alternate places, then we will take the sum of remaining places, then we will take the difference of these two sums, which comes out to be, now by divisibility rule of 11, this final result should be a multiple of 11. So it can be either 0 or 11. We cannot take all the multiples of 11 here. We cannot take minus 11, 22, 33 and so on. Why so? Because dollar and hash, they both are digits. So the maximum value of dollar minus hash will be 9 and the minimum value of the same expression will be minus 9. So for this 9 there is only one solution, that is 9 minus 0. There is only one way. For this minus 2 we have various possible solutions and they are, so in total how many solutions are possible? These 8. See, we are going from 0 to 7, so these are 8 values and this one. So in total how many values are possible? They are 9. There are 9 such numbers. That is the answer. Let us move further. Now we will discuss a new type of divisibility questions. Before starting questions, let us see the shortcuts. It says that a raised to power n plus b raised to power n, if n is odd, it will be divisible by a plus b, but it will not be divisible by a minus b. Let us take an example. Since we need n as odd number, let it be 3. It will be a cube plus b cube where the power is odd. Now, do we have any formula for this? Yes, we do have. This is a plus b into a square minus ab plus b square. So, a cube plus b cube is divisible by a plus b. Similarly, a raised to power n minus b raised to power n, where n is odd, will be divisible by a minus b. A raised to power n plus b raised to power n, where n is even, it will not be divisible by a plus b or a minus b. But if we have a raised to power n minus b raised to power n, where n is even, let us take n as 2. So we will have a square minus b square. As we can see, we have a formula for this, a minus b, a plus b. Now this expression will be divisible by a minus b as well as a plus b. So we can generalize these formulas as well. So let us discuss a question based on this concept. It says 18 raised to power 2000 plus 12 raised to power 2000 minus 5 raised to power 2000 minus 1 is divisible by which of the following options? Now, as we know that 323 can be written as 17 into 19. 221 can be written as 13 into 17. 299 can be written as 13 into 23. And 237, this can be written as 3 into 79. So, let us take the expression. If we combine 18 raised to power 2000 and 5 raised to power 2000 and 12 raised to power 2000 with 1. Let us write them together. Since 1 can be written as 1 raised to power anything, that's why I have written it as 1 raised to power 2000. Now, if we apply the shortcuts, we'll get, since the power is even here, 2000 is an even number. So we know that a raised to power n minus b raised to power n, where n is an even number, it will be divisible by a minus b and a plus b. So we can say that this number is divisible by 13, 18 minus 5. Similarly, the other expression 12 raised to power 2000 minus 1 raised to power 2000, it will be divisible by 12 plus 1, that is 13 again. So this is divisible by 13. So 13 should be a factor of the complete expression. Similarly, again, we will combine them but in a different manner. Again, applying the same shortcut, the first expression should be divisible by 18 minus 1, which comes out to be 17. Similarly, the second expression should be divisible by 12 plus 5, which is again 17. So we can say that the complete expression will be divisible by 17. So we have concluded that the complete expression, the term which was given in the question, is divisible by 13 as well as 17. That's why second option, this is the answer in this case. I think this question is clear now. The concept is clear. Let us move to practice questions. Now there are some practice questions. And this is the answer key. To learn more concepts, log on to hitbullseye.com. Happy learning. Thank you so much.